You know, we walk into buildings every single day and we never give it a second thought. But all around you, right now, there's this silent network of protectors. It's an invisible system, really, designed to save your life from one of our oldest threats, fire. In this explainer, we're going to pull back the curtain on the hidden fire safety features that are literally engineered into the walls around you.
So why does this matter so much? Well, let's just start with the stakes. This number, 7, that's the average number of people who died each day in home fires in the US, according to a 2013 report. It's a really sobering number that reminds you of the constant risk we face, even in the places we're supposed to feel the safest.
So what's actually causing these fires? Well, take a look. The biggest culprits aren't some kind of freak accident. They are literally part of our daily routines. Cooking and heating equipment, right at the top of the list. It's these totally ordinary activities that can carry an extraordinary risk, and that is precisely why all these hidden protection systems are so incredibly vital. And get this, here's a critical fact most people just don't realize. The biggest danger in a fire often isn't the flame itself. Nope, it's the smoke. It's toxic, it's disorienting, and it can be absolutely lethal in just a few moments. So a building's first line of defense has to be managing this silent killer.
Okay, so to understand how a building fights back, we first have to understand the fire itself. And it all boils down to some pretty simple science, which is perfectly captured by something called the fire triangle.
This right here, this is the core principle. Every single fire, I don't care if it's a tiny candle or a huge inferno, needs these three things to exist. And every single fire safety system we're about to talk about is designed to remove at least one of them. So let's break them down.
First up, you need fuel. Now, in a building, fuel is everywhere. I mean, it's the wood in the structure, the drywall, the carpets, the plastic in your furniture, even the insulation hidden in the walls. The building itself is basically the main source of fuel.
Second, you need oxygen. And yeah, this one's kind of the easy one, right? It's just in the air all around us, which, as you can imagine, makes it the hardest part of the triangle for any safety system to control.
And third, you need heat. This is your ignition source. It could be a spark from some bad wiring, a flame from a cooking mishap, or an overloaded circuit. It's that little bit of energy that kicks off the whole chemical reaction.
So that's the real challenge, isn't it? A building is basically this giant container of fuel and oxygen, just waiting for a spark. The question is, how do we engineer that container to actually fight back? Well, the answer lies in a multi-layered defense system. And that very first layer? It's all about getting out.
The absolute #1 priority in any fire is protecting human life. And that starts with creating a clear, protected path for every single person to get out safely. In the world of fire safety, they call this the means of egress.
Now, this means of egress isn't just a single door. It's more like a three-part journey. It starts with the exit access. That's the hallway that leads you to the exit. Then you have the exit itself, a protected space like a stairwell that takes you down safely. And finally, the exit discharge. That's the path from the bottom of the exit to a safe public area way outside. And this is the heart of that whole escape system, the protected exit stair. This is not just any old stairwell. Its walls, its doors, its entire enclosure are built from special fire-resistant materials. It's basically a safe tunnel engineered to keep smoke and flames out just long enough for everyone to get out.
But, okay, getting people out, that's only half the battle. While you're making your escape, the building itself is actively fighting back to contain the fire. Let's dig into how it does that.
Now, this fight has two very clear goals. First, and most important, is protecting the occupants. That means slowing the fire's spread to buy precious time for evacuation. And second, protecting the building itself from collapsing, which keeps people inside safe and also protects the firefighters who are on their way.
A key strategy here is something called compartmentation. Seriously, think of it like the watertight compartments in a big ship. The building is divided up into these fire-rated boxes using special walls and floors. If a fire starts in one box, the whole idea is to keep it trapped there, starving it of new fuel from other parts of the building. It's a direct attack on the fuel side of that fire triangle. And all of this is made possible by the building's hidden armor. Steel columns, which can get weak in extreme heat, are coated with this spray-on fire protection. Openings and walls are filled with special fire-rated glass that can handle insane temperatures. Every material is specifically chosen to resist fire for a certain amount of time.
But just having strong walls can only do so much.
To really fight back, buildings need active systems. And just think about this. It can take as little as 4 minutes for just one sprinkler head to put out a small fire. That is a direct assault on the heat side of the fire triangle, cooling the fire down before it ever has a chance to grow.
Of course, none of these systems are any good if nobody knows there's a fire in the first place, right? So the final piece of this puzzle is the network of sensors that gives us the most valuable thing in any emergency, an early warning.
What's really interesting is that fires actually evolve in stages, and there's a specific type of detector for each one. So in the very first, or incipient stage, a fire releases these invisible particles that are picked up by ionization detectors. Then, as it grows and starts to smolder, creating visible smoke, photoelectric detectors get triggered. It's only later, when you get actual flames and high heat, that flame and heat detectors will activate. This layered approach is all about giving the earliest warning possible.
The very second one of those detectors goes off, the building's central nervous system just kicks into high gear. And it's way more than just a loud noise. It's a coordinated response. Heavy fire doors automatically close to seal off those compartments. The HVAC system shuts down to stop smoke from spreading, which attacks the oxygen side of the triangle, and elevators are recalled for the firefighters. The building literally transforms into a machine that is designed to save you.
So what's the big takeaway from all this? The space you're in right now, it isn't just passive shelter. It's an active, intelligent machine that is filled with hidden protectors. From how wide the hallways are, to the materials deep inside the walls, to the sprinklers right above your head, it's all part of this incredibly intricate system. Now that you've seen how it all works, what are you going to notice differently the next time you walk into a building?